This is StarTalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist, and this is going to be a Cosmic Queries edition, the ever-popular format that we started many years ago, and it just keeps going strong. And today's topic is going to be the multiverse. I got with me my co-host, Chuck.
Hey, Neil. How are you?
Chuck, nice. You know, you getting such a schooling here with all this cosmic knowledge.
Yes,
and
I
we're gonna have to give you a degree of your own.
No, because then that normally once you get the degree, that means that your time at the institution is over unless you start paying more money.
Okay, so they kick you out the front door.
Right.
Okay.
So I'm just going to continue to. I'm just staying in school forever. That's all.
Lifelong learner.
That's
all
it.
Right.
Just stay in school.
Well, this topic is in part celebration for the release of the second StarTalk book. And guess what that book is called, Chuck?
Let me take a stab at it. Could it possibly be Cosmic Queries?
Cosmic Queries,
yes.
Inspired by this very format. There are questions that people just ask that are so deep and so interesting, and not all of them can we get to it on a podcast. And so we have to take it to the book. And so there's a whole section in that book on the multiverse.
Nice.
Yeah. And I learned almost everything I know about the multiverse from our guest today. And that is the one and the only Max Tegmark. Max, welcome back.
Thank you.
I've had you in other events at the museum for Hayden Planetarium, panels and things. It's just always good to know you're in arm's reach of us.
Thank you. But you just said something dubious. You said the one and only Max Tegmark. And if you take the multiverse seriously, I'm not the one and only.
Damn, I just got schooled on my first sentence. But Max, we go way back. I mean, when you were at the Institute for Advanced Study and I was postdocing at Princeton, I think that's when I first met you and I followed your career. It's been a brilliant melange of topics that are just so interesting. And the multiverse is the least among them that I have found interesting in your career. So we'll have to have you back for other topics for sure. Plus, Chuck.
Wow, that is a serious compliment.
If
you know what I mean? If the
universe is a side, it's a side gig.
Multiple universes are the least interesting thing.
I'm sorry, I'm just leveling with you here.
Wow.
To be honest, guys, it has been officially my side gig all along, just so I wouldn't tank my career with it. Because when I was a grad student, I was already fascinated by this, but nobody else seemed to be, and it was generally considered a bit too fringe. So I played the multiverse very close to my chest, and I even wrote some papers when I was a grad student. I didn't show my advisor until after he had signed my PhD thesis.
Under a pseudonym, John Doe. Yes, okay.
Oh, that's so funny.
And it's so weird how now gradually some of these topics have actually come in a bit from the cold and gone from being just considered career ending to being things that are considered legitimate scientific controversies that we actually can talk about openly at physics conferences.
So you're a professor of physics at MIT, of course, the Massachusetts Institute of Technology, basically up the street in Cambridge, Massachusetts. And Chuck, I've always been jealous of this man's name. It's like movie star Max Tegmark.
It is
starring.
It does. It's it could be either the star of the show or the producer. This is a Max Tegmark production.
Productions.
Yeah, it works. Exactly. It works either way.
All of the above.
Right.
And Max, you've got a couple of books under your belt, at least. One of my favorites is Our Mathematical Universe, where you argue that everything is math, and if everything is math, someone could have programmed it that way. And so a brilliant exercise there. And of course, Life 3.0. Where you're exploring the future of what we even think of as life. And I've enjoyed both of those books. So thanks I think of them as a gift to civilization to share in how you think about this world.
And I enjoyed the conversation that I heard on NPR about your book about mathematical universe.
Okay. But now we have the guy, we got him ourselves.
Exactly.
Here, okay? We don't have to share him.
Max, actually, I just have to ask a trivia question that I changed the name of that book in the last second for reasons we're going to talk about now. The first title was The Mathematical Universe. And then I thought, that's so arrogant. If we really believe that there are other universes, we shouldn't just say the universe, ours. We should be more humble. And acknowledge that it might just that our universe might not be the only one.
Okay, all right. So,
It's just like
so we went through
solar
a
system.
brief last-minute title change, so that you wouldn't sound like an a-hole.
Right.
We used to talk about the solar system,
Right.
and then we realized, oops, there are others, right?
or the universe, and no, we're not saying that anymore. It's our universe. I
Right.
like that.
Yeah.
No, it's a good shift for that.
You changed
There's
the universe into the Humbleverse. That's cool.
Ooh, Humbleverse. Very good, Chuck. Making up words on the spot.
For humility in general, I think Homo sapiens.
Yeah. Well, yeah.
So, Max, tell me, what motivated people to you and your, either you early on when you were doing this sort of under the cover of night to what is now mainstream research on the multiverse? What motivated it?
Well, I think, first of all, throughout human history, we've had this epiphany again and again that, hey, stuff is bigger than we thought. And we used to go into it with this hubristic assumption that all we knew about was all there was, kind of like an ostrich with a head in the sand. And then people realized.
Oh, by the way, the corollary to it's bigger than we thought is we're littler than we thought.
Exactly. We realized actually
the flip side of that coin.
We're part of this we're standing on this huge round ball in space, which in turn is just part of this gigantic solar system, part of a galaxy, part of a cluster of galaxies, part of a supercluster, part of this that we then would call our universe. And why stop there? So people started wondering, could there be still more? And the earliest people got into much more trouble, than I ever did in grad school. Like Giordano Bruno, 400 years ago, started talking about how maybe space went on forever. And you know what happened to him, right?
Yeah, he was burned at the stake upside down with a something plugged into his mouth.
Wow.
So that even in death, he could not repeat these heresies.
Wow. Talk about
they drove a stake into his mouth so that even when he died,
that's what I liked about that time. The overkill. Overkill. Everything was overkill.
So, now, I went to Campo dei Fiori actually in Rome where this happened, and I started to think, compared to that just getting burned on the job market is a lot less of a threat. So we're making some progress, and
it's a little bit of progress.
But
just to be clear, that square that in Italy, there is, in all fairness, there is a statue to him where he's looking very solemn, but it's a very honorific statue in his memory.
Yeah. It is.
Small consolation for being burned at the stake.
And but what drove
I'll take life. You keep your statue. Is that what you're telling me?
Thank you. Exactly.
Yeah. But you asked this very good question. What drove us to these things? And it's basically just natural logical steps. It's just, Euclid himself postulated that space is infinite, right? When we were kids and we started wondering, does the space go on forever? It seemed pretty natural that there wouldn't just be an end to it, right? So if you just take that idea logically, then that means that the part we can see, right, this is finite because light has only reached us from this spherical region that it could get here from during the 13.8 billion years since our Big Bang. So if that's what we call our universe, then by definition, there are other regions of space just as big, just as cool. And it's sort of hard to dismiss. Right now, I don't have a single astrophysics colleague anymore who thinks space magically ends right at that edge. And in fact, you can just wait one day and you see some more light arriving from farther away, right? And then, so that's what I call the level 1 multiverse, just other regions of space that we haven't had any access to.
Wait, so initially, it wasn't that people were motivated to try to answer some other question. They just more fully explored what we were already thinking and already knew to be true about the universe. So in that sense, it's not some epiphany. It's just an extension of what we're already thinking. Is that a fair way to think about your level 1 multiverse?
I think so. And I think a lot of the pushback, honestly, wasn't really based on science so much, but based on arrogant hubris. The reason Pope Urban VIII or whatever was so pissed at Galileo, wasn't because he had a good scientific argument, but we were so stuck to the idea that everything orbits around us. We humans are so important, and we didn't like to be demoted to just being an average planet in an average solar system orbiting a galaxy, et cetera, et cetera. And I think we see still a little bit of that today. Some people argue that they don't like this idea of reality being even bigger just because it makes their egos feel even smaller.
You know, after the last 4 years, I can't imagine that people would actually hold to those sentiments.
All right. So what I don't know, because I haven't quizzed people, is what are they thinking of when they hear multiverse? And my sense is they're thinking maybe a parallel universe that you might be able to sort of move between at some distant future time. So is there any truth to the concept of a parallel universe in the way it's commonly thought of in the public?
Is there an evil Chuck somewhere?
With a goatee? Oh, you already have a goatee.
Yeah.
Is there a clean-shaven evil Chuck?
You are the evil Chuck.
Oh, my
Is there
God.
a good Chuck?
Oh, my God, that's right.
Just think that through.
What's incredibly confusing here is that different people mean different things when they say universe, and they mean talk about different kinds of. And in fact, I remember once very vividly, Martin Rees had organized a conference in his house about these forbidden topics. And I just heard
Chuck, these are kind of friends we have. That you get that,
Right.
you know, you get invited for tea and you solve the issues of the universe.
Well,
okay, go on.
because, you know, this was considered pretty taboo back then, but because Martin was organizing it, people still came and behaved. But I noticed that two people were arguing about the multiverse, and I realized they're talking past each other. One guy was talking about what we call the inflationary multiverse, which is just really big space, and we can get back to that. Another guy was talking about the quantum multiverse, and they thought they were talking about the same thing. So I felt I stood up and said, hey, wait a minute. Aren't there actually four different kinds of multiverse that we should give different names to not confuse ourselves so much? And then I wrote that up in the book you mentioned. So what I call, first of all, our universe, right, isn't all of space. It's just this part of space.
But just to be clear, the book that you're talking about is you posted something. It's online, which is a very clean and clear exposition of the multiple levels of the multiverse, and that's what we referenced when we fleshed out our section on the multiverse in Cosmic Queries. So I just want to be clear that you're not just pulling this out of your ass. This is you've thought about this for a long time.
So I think it's very important, but just be clear on what we're talking about. Yeah, thank you. So, if by our universe we mean what astronomers call our observable universe, it's just a spherical region of space from which light has reached us. Then, what I call the level 1 multiverse is just other parts of space that are so far away that light hasn't reached us yet. Level 2 multiverse is what you get if you take seriously Alan Guth and Andre Linde and others, and the theory of inflation that made our space so big, which says that far, far away in the same space now, you have something much more diverse than you might have thought, where even the number of different kind of quarks could be different, or the sort of forces that are there are different, and we can talk about why. And then there's this third kind, and that's what gets more into the parallel evil feeling thing, which has to do with studying not the big, but the very small, studying quantum mechanics, where you can argue, and people love arguing about that at physics conferences, that in some sense our reality feels like it's splitting out into parallel branches, and that's the whole. If that is true, you can tap into that weirdness by building quantum computers. And then finally there's the fourth one, which is so weird that almost nobody except myself believe in it, which is the biggest. And I think of all of this as basically Russian dolls. They're nested, they're all inside of each other, right? You start with our universe, many of those, that's level 1, many of those that makes level 2, many of those makes level 3, and many of those makes the ultimate one, the fourth level.
So wow. These are multiverses of multiverses.
That's right.
But the only one that ever gets any real attention is that kind of, tree limb version that you depicted, this splintering, where there's so many different infinite paths that are separate yet existing simultaneously. That seems to be the one that captures the imagination of every sci-fi writer and even Rick and Morty, which is like a hugely popular show. I mean, it's because I think you could do so much with it. There's an infinite number of Ricks, and they're all geniuses. So you have an unlimited reservoir of stories to tell.
Chuck, Max is Rick. Okay. We got to take a quick break. When we come back, we'll go straight into our questions from our Patreon members when StarTalk Cosmic Queries returns. We're back. Cosmic Queries, the Multiverse edition. And Max, we've got Max Tegmark, professor of physics from MIT. I've known him for 25 years. And no, longer, 30 years, I think. And yeah.
In every universe.
In every universe. Thank you, Chuck, for clarifying that. Max, you're into so many things, into AI, into most recently you've been thinking about news and the biases in news. We have to get a whole other show on that one. But I just love the work you're doing. It's fun to follow you from afar. And so we've got you on this program to talk about the multiverse because that's one of your many expertise. And Chuck, you've got questions for us. Let's do it.
Okay, let's just jump right into all the questions that we have taken from our Patreon patrons, the people who support us out of their substance to keep our show going. So thank you guys for your support. And if you are listening to this and you want to be a Patreon member, go to patreon.com/StarTalk and give us some support, and maybe I'll read your. Maybe
I don't know. That's how you're going to end that.
Yeah.
And then maybe I'll think about it.
Maybe I'll think about reading your. No, of course I'm joking. Of course I'll read your letter and I'll butcher your name. No doubt.
Okay.
No doubt. Here we go.
Give it to me.
All right. This is Eric Gross. He says, "Hello, fellow Earthicans."
I said fellow Eric because that's my middle name.
Oh, cool.
Ericans. Oh, yeah.
Ericans. Yeah, Earthican Ericans. Well, either way. Can you explain the mind-boggling idea of infinite infinities? Oh, wow.
Ooh.
Wow.
That's a good one.
That's a great question.
Well, how about this? Wait, so Max, let's start simple. And let me ask you, what does it mean for one infinity to be bigger than another? And then let's take it from that into that directly into the question. Let's drive the truck right into that question.
One infinity big. Wait a minute, guys. Give me 1 second here.
What, Chuck?
Great question.
Right.
So if we,
Chuck is.
I gotta get this little pipe here. If we gonna talk about one infinity being bigger than another, I'm just saying, I need to be prepared.
The pipe has to be right there. Okay.
Exactly.
So if you have a pile of oranges and you have a pile of apples and you want to know is it the same number of apples as oranges, the way you do it is if you can pair up each apple with exactly one orange, you say the two numbers are the same. So now play that game with infinities, and weird stuff happens. For example, you might think that there are more numbers 1, 2, 3, 4, 5 than there are even numbers 2, 4, 6, but they're actually the same because you can pair them up. I can pair up 1 with 2. I can pair up 8 with 16. I pair up every number with one that's twice as big, which is always even. So it's very counterintuitive. So for a while, mathematicians started.
But just to be clear, you just said something, but not everyone knows this.
Yeah,
Max, that twice any number, any whole number, is always an even number.
Thanks for clarifying. Yeah.
That is always the case. So you can't take twice anything and end up twice a whole number and get an odd number. So when you say twice the number, that's always even. That's a fundamental fact about mathematics. Okay.
That's right.
Pick me up.
The quite weird conclusion is that some infinities, which intuitively would seem like they're much bigger, are actually all the same size. And some mathematicians start to think maybe all infinities are the same size. But then George Cantor came along and said, no, there are some infinities that are even bigger. And he proved famously that the number of real numbers, like 3.1415 with infinitely many decimals, that there are actually more of those than the numbers you can count. And after that, people have realized that there's this whole tower of infinities. So what's that got to do with parallel universes and this question? Well, it's got a lot to do actually with the level 1 and the level 2 multiverse. Because
wait. Chuck has to take a toke. Okay. Toke break.
Yes, exactly. So far, this is great. This is great.
Take a deep breath because I'm going to tell you one of the things that I find the weirdest. This is one of the weirdest things I believe to be true.
And if Max finds it weird, brace yourself. Go.
Right, exactly.
That it is actually impossible. It is, according to Einstein's theory of general relativity, possible to take a little piece of space, just finite, and inside of there make an infinite space that's doesn't stick out anywhere, and actually infinitely many, and make many different infinite spaces inside of this finite thing. It's a bit like the ending of the Men in Black. I don't want to spoil it for those who haven't seen the film.
The movie's been around long enough. Don't worry about it.
So Alan Guth, Andre Linde, and others came up with this most popular theory we have so far for what put the bang into our Big Bang, right? And made this expanding universe of ours, starting with something tinier than an atom. It's very, very big. And the ultimate party trick is inside of this tiny region, they can not only make one space, which when you live in it, feels infinite. That's a level 1 multiverse for you in there. So it has room for infinitely many of our universes, but you can have infinitely many of those within there. And
so you can have an infinite number of infinitely large universes in a finite universe.
Basically, that's why it feels so utterly weird. And the way that general relativity kind of pulls this trick is because even though it was a finite volume of space, it has an infinite amount of future time to play with, and it keeps stretching the space. And then general relativity has this funny thing where it can kind of mix up space and time, so that for someone who lives inside this, what they consider to be space was something that you might have considered a little bit of time. And I don't want to get too nerdy about this, but Einstein told us that what really we should.
Only now are you saying you don't want to get too nerdy? It's only just occurred to you now.
I think I already blew it. But Einstein told us, right, that we shouldn't think of reality as a 3-dimensional place where stuff happens, but rather as time being just a fourth dimension in this never-changing place called space-time. So if life is a movie, then space-time is the whole DVD. And basically, because you have this infinite future time to mess with, if you can sort of bend your definition of what space is in there, this is how Alan Guth and Andre Linde and Alex Vilenkin and others have demonstrated this apparently crazy thing, that maybe everything we see here, an infinity of infinities, could actually ultimately be emerging inside of this little bubble.
Wow. So just to clarify your DVD analogy, what you're saying is we live as prisoners of the present, transitioning from our past to our future. So we experience a moment in time and many places in space. But if you have the whole DVD of the movie, then your entire timeline is manifest in that place.
All at once.
All at once.
All the time.
Of your life is in that DVD. And
Wow.
you can have random access to it. If you can move throughout the time coordinate. Is that a fair reference to how you used the concept of DVD?
It is. And
okay.
That's right. Einstein even told some of his friends that they shouldn't worry so much about his death, because he argued that it's just from the space-time perspective an illusion. It's not like.
Because I'm already dead, man. And so are you. We're all dead, man. And we're not. I haven't even been born yet, man. And I'm dead. What?
It is pretty weird, Chuck. I mean, I'm sure sometimes people come up to you when they're lost and ask, hey, excuse me, but where am I, right? But they never come and ask, when am I?
Right.
In colloquial English, we treat time as a very different sort of thing as space. Whereas when we say, what's the time? That's actually very arrogant. Just like talking about the universe or the solar system. What is the time? I mean, that's saying that somehow the instant when we're having this experience is the only time. I mean, all the other times, past and present in space-time, have just as much claim to be real. They certainly felt real to people who had experiences then, right? So if we want to be a little bit more rigorous, we should always go ask people, excuse me, when am I? To my watch, you are right now at this particular time having this experience.
Wow. Okay, so that doesn't have the arrogance that it otherwise would by asking what is the time.
I mean, it's like going up and saying, what is the place?
Right.
Of course, where I am is the only place. So.
All right, Chuck, give me some more questions.
All right. Wow, that was way to kick things off. That is something else. All right, let's move on to that other level you're talking about. This is Chris Hampton. Could the parallel universe theory and the multiverse theory be combined? For example, we are living in a universe with billions of other organisms, but what if each organism in the universe is itself a universe on a relative scale, each one thus containing billions of organisms, so on and so on. So he's taking your nesting doll and breaking it all the way down to every single organism.
Right, but yeah, he's thinking. So Max, if we have as a lead into that the early concept of the atom, where people said, "Oh my gosh, atoms have structure, and there's a nucleus, and there's electrons orbiting, so that's just like the solar system. So maybe it's like turtles all the way down." So how do we go from any understanding of scales of everything's just on a different scale rather than something that's a completely different universe unto itself?
Yeah, it's a very good question. We see, of course, in nature this really beautiful hierarchy, right? You have some quarks stuck together into neutrons and protons that are stuck together into this big thing we call a nucleus, stuck together in an atom, and then you can make molecules and cells, and you can make Neil deGrasse Tyson and this society and a planet and a galaxy, etc. What's different about the hierarchy of universes is it's not just that the hierarchy exists, but by definition, I like to define a universe, our universe, as everything that we could possibly have any access to, with unlimited funding and never mind other stuff that's in the way, right? So if you look at, for example, if you're one person in a society, there are a lot of people you haven't met, but you could in principle meet them. So they're not part of another universe. You could in principle go to Uruguay even if you've never been there, right? But you can never go 100 billion light years in that direction, even if you wanted to. It's just off limits to you. So we're a bit more, that's basically the definition I think is helpful about universe. Some people,
but otherwise we'd use the term sort of poetically or metaphorically, like the cell is a universe unto itself.
Yeah.
So I think that's fair poetically, but you're saying from the world of physics, no, that's not how we use the term.
Yeah, exactly. Right. And I mean, it's whatever. We need to have we should have a word for everything we can access. It's very important for us, especially in the future, both if we're curious, that's the limits of what we can observe. And if we're ambitious, that's also setting roughly the limits of where we could ever go in the future. So if you don't want to call it universe, call it schmooniverse or make up another word for it, but it deserves to be called something, right? And where space, I think, is a word that's better used to actually describe all of space. And it's not the same thing. Space is probably bigger than our universe.
We have confirmed that Chuck lives in the schmooniverse, just to be clear.
Yes, the schmooniverse. It's where all dismissive people live. Universe, schmooniverse. Yeah, whatever.
Could it at least be the tuniverse? So it's
or I don't mind the tuniverse. Now you're making me hungry. Well, Chris Hampton actually, it looks like he, from what you just said, is... Speaking of smoking, is that whole, hey man, there's a universe in my thumbnail, like that whole vibe. That seems to be where he's coming from. Right. All right, cool. So let's.
By the way, again, that was reminiscent of the ending of Men in Black, with the galaxy on the belt of Orion, which was the tagline there. But yeah, you got to see the movie.
But it is. I like what you said, Neil. The reason people use it poetically in that sense is because we refer to things poetically as a universe unto its own. Basically, if it really is doing its own thing and not interacting with the rest, right? Which is what we're trying to capture scientifically here.
Okay. So now I want to ask my own question, but I don't want to take up these people's time.
Chuck, are you a Patreon member? If not, shut the hell up and read the next question. Okay.
Well, Neil, I got to tell you, you have bested me, sir. 'Cause that was a damn good point. Oh my God! Hold on. Now I got to go online right now. Get on Patreon. I gotta get on Patreon right now so I can ask my question. All right, here we go. This is Curtis. Oh man, you really got me with that one. Okay, this is Curtis Lee Zeidelhack, I think. Zeidelhack. Yeah, he says, first and foremost, my name is pronounced Zeidelhawk. Okay, so I was wrong, but I got it close. Okay. Conceptually, I do not really understand how a multiverse affects our universe. What is the most important effect on our universe?
And I'm going to paraphrase that and say, is there any observational evidence
Right.
that such a thing exists? And we're going to get to that in the next segment. We got to take a quick break.
Cliffhanger.
So when we come back, more StarTalk Cosmic Queries with my longtime friend and colleague, multiversist Max Tegmark on StarTalk. We're back, StarTalk Cosmic Queries, Multiverse Edition. Or is it the Schmultiverse? We're trying to figure out a creative naming of these things. I got Max Tegmark. Max, are you on social media?
I'm Tegmark on Twitter.
Tegmark. There you go.
Nice.
The only Tegmark in the world.
That's it. That doesn't even need a first let, just Tegmark. Like,
Well,
he's
if you believe in the multiverse, then there's undoubtedly some other planet out there with someone who looks exactly like me and talks like me. But the first one you come to will probably be named Schmegmark or something else, because, it's if you take seriously this idea that space is just infinite and started out a little bit differently in different places, it's much more likely to get someone who is kind of sort of like me, but not exactly.
right.
Okay.
There you go. Well, I mean, in the meantime, that's not a problem for Twitter. So
Plus, there's that scene where they have the whole room of a million monkeys typing away on a typewriter. And
Right.
they're trying to get the works of Shakespeare. And so they finally get one. It was like, to be or not to
Yeah, there's about a Google particles you have to put together right in our observable universe. So one with 100 zeros. So you actually have to try about a Googleplex times, which is one with a Google zeros after it until you get it right, which is why your nearest clone might be ridiculously far away. So I love the question you just asked before we got cut off there about what's the evidence for this? Is this just silly pub beer speculation, or is this science?
Chuck, who asked that?
that would be Curtis Zeidelhawk.
Yeah, he's wondering, do we see this other universe? And so the official way to say that is, do we have experimental evidence that they exist? Right, or this is just what you talk about at the beer halls.
Yeah. So it's a really great question, because by definition of what you mean by universe, you are not affected by things outside of it. So isn't that by definition untestable? And the interesting thing is, no, that's not true. First of all, if you just take the theory that space is actually much bigger than we thought and with more stuff in it, right? If that's false, that would mean that actually things kind of end at exactly the edge that we can see now. That's very testable. You just wait a little bit, and then light from farther away reaches you and keeps coming into view. And so we've already falsified that many times over. Now, there's a more profound way in which you can test this also, though. We have to remember, in science, right, we test theories. And for a theory to be testable, you don't have to be able to test everything that it predicts, just at least one thing. Take Einstein's theory of general relativity, right? It predicts all sorts of stuff that we can observe, like how Mercury orbits around the sun in a different way than people thought it was supposed to because of Newton. We can test that. We can test how light is bent by gravity, etc. But it also predicts what happens inside of black holes, which you know very well. We cannot go and observe and then come back and tell our friends about it. Why do we still take it seriously? What happens inside black holes? Because this theory of general relativity has passed so many of the tests that we could test, that we also start taking seriously its untestable predictions. And you can't just say, well, I kind of like what Einstein's theory predicts for the motion of Mercury and gravitational lensing and yada, 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 but I don't like the interior of black holes. I'm just going to opt out of that. Like if I go to Starbucks and say, I want my coffee, but I'm going to opt out of the caffeine and have decaf. That's not the way science works. If you want to opt out of the black holes, then go come up with your own gravitational theory, which doesn't have black holes in it, but still succeeds in everything Einstein's theory did. That turns out to be such a tall order that despite a lot of smart people trying, for 100 years, they've all failed. So,
Wow.
So what's that got to do with the multiverse? Well, replace general relativity now with the theory of inflation, that we talked about. It makes a bunch of testable predictions. It predicts that our universe should be expanding, that it should be very uniform.
Wait, just to be clear, you're not actually replacing general relativity. You're enclosing it.
Yeah.
In inflation, isn't that correct?
Correct. Thank you for correcting me. We take general relativity and then we add some additional assumptions to it. That there is a certain kind of substance there which behaves in a certain way, and then we do the math. And it predicts all sorts of things that we've tested now successfully with great prediction, like these ripples in the microwave background, their statistical patterns. For example, I've worked, as you know, a lot on trying to rule out this theory of inflation, and I've failed. And because of that, we take it seriously. And we also have to then take seriously the things inflation predicts that we cannot test, such as that space is actually way bigger than our universe. So
I think that's an excellent way to think about it. So if the one theory has these multiple consequences, it's okay if some of them you can't or you never will, if the ones that you can test turn out to be correct. And you say, if this is correct, I'm going to take a stronger look over. I'm going to start thinking about this. By the way, is it fair to say, Max, that if you explore the things you cannot measure, you might come up with a discovery that you can measure?
Very true, too, because very often when people have been going off and thinking about these things, which they knew they could never test, it led them to ask questions, what led them back to something
to a whole fresh way.
Could test. Excellent. For example, back in, that's another very good reason, not just we shouldn't think of these cool things just because they're fun, but they often turn out to be very useful. People started thinking about what the ultimate building blocks of matter were and atoms and so on. And people for a long time thought that was completely useless. But then by thinking about that, they invented quantum mechanics, which gave us the whole computer technology, which lets us have this podcast now and so on. And that's another example actually of exactly this same question. The quantum parallel universes, of course, we can't visit them either, but quantum mechanics predicts so much else that we can test. And it turned out to be very, very difficult to come up with a theory of physics that predicts only some sort of creation mechanism for our universe that creates only the part we can see and then stops and doesn't make anything more.
So let me ask you this with respect to what you're saying.
Chuck, you're not a Patreon member yet.
Maybe you signed up during the break.
That's right. You never know what I did during the break.
I don't know what you did during the break.
Yeah, that's right.
All right, I'll let you slip one in. Go.
All right. So, Max, with respect to what you just said, are there things that we are able to observe or at least able to observe the forces thereof that remain a mystery that may in some way be attached to the multiverse theory?
I would say...
Isn't that what we just answered? Is that... Are you saying, Chuck, if the multiverse is what it is there some piece of it dangling and visible in our own universe?
Yes, that we're observing. But we're actually observing, but it's still a mystery. Like, are there mysteries that are observable that...
I got it, Chuck. Yeah. I'm going to recast your question. You ready, Chuck?
Okay, go ahead.
Are there deep mysteries in our own universe that could themselves be evidence of a multiverse, and we have yet to put the two together? How's that, Chuck?
That's what I'm saying.
Okay. No, that's not what you said. You mangled it.
But I didn't mangle it enough that you didn't know what I was saying.
And I will answer it with a resounding yes.
Okay.
Take dark energy, for example. We all know by now that we have no clue what 95% of our universe is made of, and most of it is made of this weird stuff called dark energy. And what's really odd about it is when you work out exactly how much there is in the sort of most natural units of measurement that we would do in physics, we get this number which is 0.00000 with 123 zeros and then a 1. And we wonder, like, why is that? It turns out, if you look closer, that if you have a little bit more, we would all be dead. There wouldn't be any galaxies actually ever formed. And if you had less, so this was a bit negative, we would be inside of a black hole by now and also not having this conversation. So why is it that our universe was so fine-tuned that the amount of dark energy was dialed into just that very special value that let us have this conversation? That is one of those mysteries, Chuck, I think that you're fishing for here. Some people said, well, tough luck. Sometimes we're just lucky. Let's just be grateful for it and shut up. Other people said maybe this is evidence that we were designed either by a divine being or by some simulator who tuned our universe specially to be able to have life.
In the parents' basement, they did this. Yes.
But then, if you actually have this thing with space being very big, with parallel universes, with all sorts of different values of that knob setting in different places, suddenly you have an actual simple explanation for this. The picture you get then is that the bigger space is like the Sahara Desert. It's mostly just a barren wasteland with no galaxies. But in a few places, that knob is set just right, and you have an oasis where there is life, and there are galaxies, and there is StarTalk, and surprise, surprise, of course, that's where we're going to be having these conversations. So,
well, just to be clear, it's not that it was set that way. It's that if you have an infinite or a huge number of these universes where the knobs are set at random, one of those random knob settings will be the right combination for us.
It's like tuning your dial up and down. What used to be radio, kids. There used to be a thing. Used to be this thing called radio, guys, where you would actually tune your dial, and like most of it was just white noise and empty. Yeah. But every once in a while, you would come across somebody talking or some music or something like that.
Exactly.
Oh, that is freaking brilliant. God, I love science. Okay.
Right, okay. Keep going.
All right, here we go.
We got just a few minutes left. See if we can squeeze them all in. Go.
All right. Here we go. This is Woody, okay? I'm going to read this because he's just going.
Did you pronounce his name correctly?
Yeah, I think I got it right. Woody says, what are your thoughts on how a multiverse could actually begin? Would each one require a Big Bang? And how many of those would end up with a Chuck being possible?
Okay. The Chuckiverse.
Yeah, that ain't... Whatever.
So Max, does everyone have a Big Bang just like us? That's a great question.
Yeah, so I've actually had a total rethink about the Big Bang concept, because first I was taught that that's the beginning. And now it's pretty clear, if you take inflation theory seriously, you should think of the Big Bang just as the end of this crazy creative inflation process in our little part of space, when things calm down enough that you can make galaxies and evolve a Neil and a Chuck. And in other places, it kind of keeps going. So even if you have only one bang, but that it keeps going ad infinitum, you will end up having many, many different regions where it stops, and you get what we would call a level 1 multiverse, with a universe. So all it takes is ultimately one bang to get it all. And if you have each one of those places where it stops being actually infinite, then no matter how unlikely it is that you, Chuck, arise because the particles started out in exactly the right configurations for your mom to meet your dad and all of that, the probability wasn't zero because it happened here, and you're rolling the dice infinitely many times now, right? So it's guaranteed.
Well, there you go. And by the way, both my parents lost on that bet. So on the roll of that dice.
I mean, by making you, is that what you're saying? Okay. All right.
Believe me, I was not a good kid. All right.
Keep it going.
Here we go. This is Cameron Bishop. Hello, Max. Hello, Neil. I've always been curious. Is it flawed to ask what's between these universes?
Love it.
Is that measurable space?
Ooh.
That's a great question.
So between the different level 1 multiverses and the level 2 multiverse, there is still space. But that space in between is still doing this inflation thing and doubling its size over and over and over again in regular intervals. That's why it's impenetrable. Because if you start flying through, you go for a while, and now you're still farther away from where you're supposed to go.
It's expanding faster than you can gain distance through it.
Exactly.
Exponentially. Wow. Okay.
That's great. That's super cool. All right. Okay. Here's.
But in the quantum multiverse, there are actually whole other space-times. It's not one space-time system, right?
The quantum multiverse, the level 3, lives in a bigger space we call Hilbert space, which may even have infinitely many dimensions. So
I hear the rents there out of control.
The Hilbert space.
Yeah, property values are just off the charts in Hilberg. Something has to be done about Hilberg, damn it.
So what would you call what was between those quantum universes?
Yeah, in the quantum case, it's much more tricky. When quantum mechanics was first invented, people didn't know about this phenomena called decoherence. It was only discovered by Hans-Dieter Zeh in 1970, and he should be more famous than he is. which is a kind of censorship mechanism that explains why we don't experience all those other weird quantum realities if they're actually there. Basically, what comes out of the math is that these quantum superpositions, as they're called, they only survive as long as they're kept secret. And whenever something gets really big, air molecules bounce off, photons bounce off, and the secret is out. It's like you tell a friend, they tell a friend, and so on. And that's why big things like us always seem to only be in one place at once. And we can only experience and measure quantum weirdness with tiny things that can keep their properties secret.
So Chuck, time for that last toke on that pipe.
Yeah, man. I'm telling you right there. That's wow. That was cool. And what's
Chuck,
it called? What's it called? D what now?
Decoherence.
Decoherence.
So
what he's saying is that we're so big we can only be in one place.
Right.
You can call them decoherent.
Wow. Okay.
No, here's Chuck. When your kids are babbling on and you don't know what they're saying, say, stop being decoherent.
Yeah, don't be decoherent, okay? You quantum dummy.
That's worse than incoherent. You are
Right.
decoherent.
You're decoherent.
Yeah, they're just decohering the whole conversation.
Oh, good.
Chuck, give me one last question and see if Max has a soundbite in him to answer, because that's all the time we have left for it. Go.
All right. Here we go. This is Jay Hunt. Greetings, Neil and Max. This is Jeff from Titan. My question is...
Titan, the moon of Saturn, I guess.
Yeah, you
Okay.
gotta love that, right?
Mm-hmm.
My question is...
That means it's full of methane gas, just so you know. Okay.
Gotta cut down on those beans, man.
Yeah, watch out for the beans. Right, go on.
My question is
On this show, you better be careful where you say you're from, because otherwise...
there you go.
All right.
Okay, he says, is a new multiverse created every time we make a this or that decision? So the idea that the infinite number of possibilities are not actually possibilities until we make one of those possibilities.
Fantastic question about the level 3.
And reminder about soundbite. Go on.
Yeah. Sliding Doors movie, watch it. Basically, if you make a snap decision that you're really torn about, right, what ends up happening might come down to the position of a single little calcium ion somewhere in some synaptic junction. And where, depending on where it is, off the things go, and you end up with a completely different pattern. And either you decide to say yes to that date and live happily ever after, or say no and do something different, right? So that a micro superposition can get amplified into something that's so different macroscopically that this decoherence thing comes along and makes these two things really, really separate. So in that sense, yes, when you make a decision that you really could have made both ways, you are, in a sense, according to, if the level 3 multiverse is real, creating two parallel realities that are equally real. And each one of you is only, of course, aware of one outcome and is going to think that's all that happened.
Oh my God.
Oh.
That is crazy, man.
I love that.
That is awesome. Oh my God.
That.
Oh, right now somewhere.
So it means you created another Chuck, but you're only this Chuck, and so that's all you know.
That other guy's actually happy.
And he's having fun.
I try to think about that every time I get a parking ticket, that there's some other parallel universe where I didn't. But then I think a bit more and realize there's another parallel universe where I got towed. You win some, you lose some.
All right. Go. Max, we got to call it quits there. It's been a delight to have you on. It's always great to talk to you and probe your brain for all the fun stuff that you're thinking about. And we'll get you on for another show, because there's more to you than what showed up here. And I want to make sure our audience knows all about it. So thanks for being on StarTalk. Chuck, always good to have you.
Always a pleasure. All
right. This has been StarTalk, Cosmic Queries, the Multiverse Edition. Neil deGrasse Tyson bidding you to keep looking up.